Hi, welcome to a video on CTs and PTs. There we go. Sometimes called VTs also. The V standing for voltage, the P standing for potential. Cool. So we're gonna try to take quite a short breakdown of CTs and PTs. We know these as instrumental transformers. Instrumental for what? Instruments for our ammeter and for our voltmeter. We're trying to wire these in a way that we get smaller chunks or smaller currents and smaller voltages that we are able to measure in our ammeter and in our voltmeter. As you know, this would be your line, your ammeter in series. This would be your live, maybe your neutral, your voltmeter in parallel. So if I have a large current, right? If I have a large current, that's an amp. If I have a large current and it'll cost, and maybe it costs too much for me to buy a meter or a measuring instrument that is going to measure 2000 amps, I would opt to get a CT. So what the CT would do, this is how the symbol looks like, and then the line is running in series. What the CT would do is that it would break down or it would step down this current. For example, if the CT had a ratio of 2000 to 5, it would break down for every 2000 amps I have to 5 amps, which is a measurable amount for my ammeter. Any commercial ammeter that you can use, you are able to measure at least 5 amps. So that's what CTs are doing. And if I have a large voltage, let me think of something crazy, 11,000 volts, and my meter doesn't measure 11,000 volts, my PT or VT allows me to take that amount of volts and put it, and I'm able to put my voltmeter just there in the secondary side, and I'll get the voltage while my power is still running normally in my main circuit. So let's look at a circuit first and just look at PTs. I'm gonna try to make it as big as I can. I'm gonna space out the lines. Let me take it all the way down, and then I'll take this all the way down, take this all the way down. Then I'm gonna have this over there. This is a bit too close to the end. Okay, cool. Excuse me. I'm gonna put this over here, and then I'm gonna have my ammeter. There we go. Cool. The swap markers. This is going to be my L1, L2, and my L3. So I'm going to have a CT in series. Okay, I'm gonna explain why it's being drawn like this in a few minutes. I'm gonna have this CT in series 2, then I'm gonna have this CT in series. You can put them just directly with each other, but I want space to be able to explain them properly. And here at the bottom would have our load, either for each phase or for a 3-phase load. Cool. And at the top here, what are we gonna put? Let's put our circuit breaker, okay? We need to have a circuit breaker. There we go, there we go, there we go. This is going to be our 3-phase circuit breaker. Cool, 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 cool. And then we are going to just explain a few things on what the CTs are doing. So I'm gonna take my smaller board to explain to you what's going on in the CT. So on the CT, what I have is, I'm having my primary current, right, for L1 as an example. And then I'm gonna put my CT in series. There we go. This is going to be P1 if I'm labeling it. P1, this is going to be P2. Certain PTs or certain CTs do label differently. Some may be H1 or H2. But if you see the 1 or the 2, you should know that the 1 is the input from where the power is coming from, and the 2 is where the going to the load. It's going to the load. So this is going to be my primary, and this is going to be going to the load. This is going to be my primary. However, this is not the secondary. This is still one line. Okay? For example, if we have a donut-shaped CT, it's just going to be passing the line through it like that. Okay? It's not that this is power is getting transformed between here and here. And certain people have that misconception, and you should delete it out of your head right now. So cool, this is my primary current. We're talking about primary currents, okay? This is my primary current here from my P1. That primary current is the same throughout from P1 to P2, right? However, it changes from the CT. This is going to be your secondary current, right? Right here. This is going to be your secondary current going to your ammeter. So cool. Let's see how we're going to break this down. I need us to know how we're going to label this, or to understand the labelings on the CT. You'll find that it'll be labeled S1 here, and this is going to be labeled S2. This is my P1, this is my P2. This is as much as you get on the labeling of the CT itself. You need to know that your line wire is your primary current. The current coming through from your S1 is going to be your secondary current. And then we'll take this and this to our ammeter. That is what we're going to try to do here by means of using a selector switch. Cool. Let's put this aside. There we go. Now we have, like what we established, this is S1, this is S2, this is P1, this is P2. And it's going to repeat. So I'm not going to repeat it for the other ones. You just have to see it from there. So what then happens is that we're going to take these to our selector switch. I'm going to try to take this just a bit slow. This is going to be our common from our ammeter. And then from our common, we're going to be selecting each of those points for our secondary, right? So this is where our secondary current is coming into. So for instance, I would take my S1 of line 1. I think I should use red here. Cool. S1 there. Take this S1 there, and take this one there. But I don't know what am I gonna do with S2, right? S2, we're gonna wire it in star. We're gonna star S2. Or as some people would like to say, we're going to join S2 together. All the S2s are going to be joined together. So like this, or let's bring this one like that. There. And then we're going to take S2 here, and then there, and then down to earth. Cool. So this is our diagram for CT. And this is going to our load. Notice how our load to circuit breaker is just a straight path, okay? The CT is not interfering with altering the current going to our load. It's only altering the current going to our ammeter. We want to break down this 2000 amps, right, into 5 amps that we're going to get here. So when we work with CTs, we work with ratios. Check your CT, right? Just like how if you check your nameplate on your motor, you need to check the information part of your CT. It will let you know what is your rating or what is your ratio looking like. And that will also allow you to know what kind of CT you should choose, right? The ratio will let you know that for every 60 amps, for example, the secondary is going to give you 1 amp. So this 60:1 ratio is basically saying this is my primary, the 60 being the primary, right? And then the 1 being the secondary. Spaceman. Cool. The 1 being the secondary side. So that's what the ratio tells us. So that's what we're doing here with our CT. We're saying in my